In the midst of rising geopolitical tensions, Boeing has taken the opportunity to significantly enhance its FA-18 Super Hornet aircraft, promising notable improvements in both performance and lifespan. The Boeing FA-18 Super Hornet has long been a key asset for the air defense forces of the United States and several allies. However, it has started to show its age, leading some countries to phase it out of their fleets. With these substantial upgrades, nations might actually reconsider its use. Here's why. And stick around because we will uncover a deadly secret of this aircraft. Before diving into why nations are interested in the newer FA-18 Super Hornet, let's take a step back to just before its first flight. The Super Hornet is an upgraded version of the FA-18 Hornet, originally produced by McDonnell Douglas and Northrop for about 23 years, starting in 1974 and introduced in January 1983. Boeing took over production in 1997 after merging with McDonnell Douglas. The FA-18 Hornet was groundbreaking in several ways, being the first aircraft designed to handle both air-to-air and air-to-ground missions, pioneering the use of digital fly-by-wire flight controls and featuring carbon fiber wings, a first in fighter aircraft. The FA-18 Hornet's origins trace back to the Northrop F-17. The U.S. Navy sought a multi-role fighter to complement the Grumman F-14 Tomcat, primarily an air superiority fighter and fleet defense interceptor. By 1989, the F-14's technology was considered outdated, leading to reduced procurement and halting production in 1991. The focus then shifted to producing more of the redesigned FA-18 Hornet. In 1992, the updated version, dubbed the Super Hornet, received its first order from the U.S. Navy. Despite its advancements, the Super Hornet retains similarities to the original Hornet in terms of avionics, radar, armament, and maintenance procedures. The Super Hornet made its inaugural flight in November 19, 1995, but it wasn't until February 2000 that the U.S. Navy officially approved it after extensive testing and evaluations. Now that we've covered some history, so what exactly are the upgrades that make the Super Hornet more superior than its predecessor? Like its predecessor, the Super Hornet comes in two variants, the single-seat FA-18E and the double-seat FA-18F, which includes an extra seat for a weapon systems officer. Compared to the previous model, the Super Hornet has 42% fewer structural parts, measures approximately 60 feet in length, 16 feet in height, and has a wingspan of nearly 45 feet. Its maximum takeoff weight is around 30 tons, powered by two General Electric F414-400 turbofan engines producing 58 kilonewtons of dry thrust and 98 kilonewtons with afterburners. In terms of performance, the Super Hornet is quite fast, reaching a maximum speed of approximately Mach 1.6, or nearly 1,200 miles per hour, at an altitude of 40,000 feet. However, its range is somewhat limited, with a combat range of around 1,275 nautical miles and a ferry range of approximately 1,800 nautical miles. The combat range decreases to about a fourth of its ferry range, ranging between 444 to 489 nautical miles, depending on factors like the number of drop tanks on board or the type of mission. For instance, during a fighter escort mission, the combat range of the FA-18 Super Hornet is approximately 462 nautical miles. This aircraft is armed with a single M61A2 Vulcan gun with a capacity of 412 rounds and has 11 hardpoints capable of carrying a maximum payload of just over 8 tons. It can carry various combinations of air-to-air, air-to-ground, and anti-ship missiles, bombs like cluster bombs and laser-guided bombs, mines, as well as decoy and surveillance systems such as the AN/AQ-28 Lightning targeting pods. The Super Hornet's upgraded avionics include the Hughes APG-73 or Raytheon APG-79 radar, ALR-67V, 3 AESA radar warning receiver, MIDS data link transceiver, and more. Initially, the first batch of Super Hornets was referred to as the Block 2 Super Hornets, indicating their upgraded configurations, including the ESA radar, avionics improvements, and larger displays. The cost of a single Super Hornet is reportedly around $67 million, but this figure can rise to as high as $125 million depending on the variant. The EA-18G Growler variant falls within this price range as well, offering additional capabilities compared to other variants. Essentially, all FA-18, including the Super Hornet, are designed with comprehensive mission capabilities ranging from air superiority to reconnaissance, fighter escort, close air support, and more. With its versatile capabilities, the Navy can achieve multiple tasks with fewer aircraft than in the past. For example, during the Vietnam War, it often required up to 6 different aircraft to fulfill various duties, whereas a single Super Hornet can now perform those tasks. This consolidation potentially saves hundreds of millions of dollars annually. The FA-18 Super Hornet is designed to adapt to new systems and technologies to counter emerging threats. Boeing has continuously upgraded the Super Hornet over the years, categorizing these upgrades into blocks. The latest upgrade package, known as Block 3, commenced delivery in 2021 with a contract covering 78 aircraft. These upgrades have spurred air defense ministries worldwide to acquire or retain their FA-18 Super Hornets for enhanced capabilities and longevity. According to Boeing, the FA-18 Block 3 Super Hornet surpasses 4th-generation strike fighter capabilities. It incorporates a new adjunct processor and advanced touchscreen cockpit displays, enabling pilots to accomplish tasks more efficiently and enhancing situational awareness. These upgraded fighters are expected to extend their operational lifespan by an additional 4,000 flight hours, totaling around 10,000 flight hours, nearly double that of similar jets. Additionally, they will have increased fuel capacity compared to their predecessors and feature a reduced radar cross-section, enhancing stealth capabilities. Now, this is where the secret is unveiled. Did you know that the Super Hornet's stealth capabilities is second only to the 5th-generation, low-observable F-22 Raptor and F-35 Lightning? This is because it employs some of the most extensive radar cross-section, RCS, reduction measures among contemporary fighters, making it more stealthy than one might expect. While the F-18 isn't as stealthy as the F-35 or F-22, it can significantly reduce its radar signature in certain configurations. For example, a clean reconnaissance loadout allows the Super Hornet to act as a forward screen, detecting stealth fighters or other airborne threats at long ranges. Removing pylons and ordnance helps lower the RCS, but the F-18 also incorporates design elements that dramatically reduce its RCS, especially in the forward quarter. The Super Hornet uses panel joint serration and edge alignment to minimize radar reflections. Close inspection reveals meticulous attention to removing unnecessary surface join gaps and resonant cavities, even during routine carrier operations. Unlike the legacy Hornet, which used grills to cover various accessory inlets and ducts, the FA-18EF Super Hornets use micro or centimeter band opaque perforated panels. Additionally, careful alignment of panel boundaries and edges scatters radar waves away from the aircraft's bore sight. Efforts to lower the RCS also extend to the air intakes, which use S-shaped ducts to hide the turbine fan blades from view. These blades are a significant RCS penalty because they are nearly perpendicular to the aircraft's direction of travel. The edge alignment of the inlet leading edges scatters radiation to the sides, reducing radar emissions returned to the interrogating system. Similar to the F-117 Nighthawk, the Super Hornet uses a fixed intake reflecting structure in the inlet tunnel to keep microwave illumination off the rotating fan blades. These design features are incorporated into the latest version of the Super Hornet, the Advanced Super Hornet or Block 3 series. Block 3 also introduces enclosed weapon pods, EWP, that allow the Super Hornet to carry external stores, while still reducing its RCS. Each weapon pods can carry 6 small-diameter bombs, 2 medium-range AIM 120 AMRAAM missiles, or an equivalent loadout of up to 2,600 pounds per pod. With these RCS-lowering features, Block 3 Super Hornets claim a 50% reduction in overall frontal RCS. There's also speculation about additional radar-absorbing materials coatings for certain mission profiles, but those details are classified. Block 3. Super Hornets also enhance their ability to detect and track 5 10th-generation stealth fighters with new infrared search and track, or IRST pods, capable of detecting gliders and stealth aircraft like the F-117, B-2, F-22, and F-35 at over 100 miles. The centerline mounted sensor, known as the Stealth Equalizer, offers better visibility than traditional nose-mounted IRST platforms. The distributed targeting processor, networked computer, exponentially increases processing power, using real-time machine learning algorithms to identify and catalog new threats for use by other friendly aircraft and assets. The high-speed, high-bandwidth, anti-jam tactical targeting network technology data link brings 5th-generation communications and sensor fusion capabilities to the Super Hornet. Together, these assets allow a pair of Block 3 Super Hornets to detect, track, and lock on to enemy stealth aircraft well beyond the range of their onboard AN APG-79 radars. A single Super Hornet using IRST can detect a stealth aircraft by spotting a hotspot at range, providing a line of sight bearing. With a second Block 3 Super Hornet, these aircraft can create a fusion algorithm, enabling the distributed targeting processor network's computational power to compute a weapons quality track and fire a long-range air-to-air missile, all while remaining outside the stealth aircraft's detection zone. The Super Hornet's AN APG-79 radar, with a new gallium nitride-based version known as the APG-79V4, runs cooler and allows more electrical power, resulting in longer range and better tracking. Combined with Block 3 upgrades, this gives the Super Hornet greater striking power and detection range. Integrating the gallium nitride-based radar and IRS sensors allows detection and tracking of stealth aircraft like the Chinese J-20 or Russian Su-57 at much farther ranges. Lastly, structural changes give the Block 3 Super Hornet a planned service life of 10,000 hours. These changes enable the Super Hornets to operate for decades, maintaining effectiveness until the F/A-XX or Next Generation Air Dominance NGAD fighter becomes operational. So, what do you think about this new F-18? Let us know in the comment section. And if you enjoy this content, don't forget to subscribe for more. Thanks for watching.